how to draw a free body diagram and determine net forces. First of all, you need to understand that there are what's called balanced and unbalanced forces. So for example, the forces on a book sitting on a table would be considered balanced because there's a force pulling down on it according to gravity, but there's a force pushing upwards as well from the table, and because they're equal, the book is either sitting at rest or it's at a constant velocity, and in this case it would be sitting at rest. Since these two forces are of equal magnitude and in opposite directions, they balance each other. The book is said to be at equilibrium. There's no unbalanced force acting upon the book, and thus the book maintains its state of motion, which in this case is at rest. When all the forces acting upon an object balance each other, the object will be at equilibrium. It will not accelerate. So once again, it could be at rest or at a constant velocity. In this case, this example is at rest. If you have unbalanced forces, then you're going to have acceleration. So the forces acting on this book are unbalanced, where you have upwards the table, downwards the gravity. These are the opposite forces of each other. And then we have the friction between the table and book surfaces exerts a leftward force upon the rightward moving book. So if the book is moving toward the right, then if it's actually moving, the forces are unbalanced. If it were not moving, but you were still pulling to the right, then there would be balanced forces. The presence of an unbalanced force will accelerate an object, changing its speed, its direction, or both, its speed and its direction. So forces are balanced. If forces are balanced, then there's no acceleration, and so either the object is at rest and your velocity equals 0 meters per second and it stays at rest, or your object is in motion where your velocity is not equal to 0 and it stays in motion in the same speed and direction, so constant velocity or constant motion. If your forces are unbalanced, then there is an acceleration present. The acceleration is going to depend directly on the net force. The acceleration also will depend inversely upon the object's mass. So for example, several of Luke's friends were watching the motion of the falling cat. Being physics types, they began discussing the motion and made the following comments. Indicate whether each of the comments is correct or incorrect and support your answers. Letter A, once the cat hits the water, the forces are balanced and the cat will stop. Letter B, upon hitting the water, the cat will accelerate upwards because the water applies an upward force. Letter C, upon hitting the water, the cat will bounce upwards due to the upward force. All three of these statements would be considered false. First of all, once the cat hits the water, the forces are balanced, and this is true in all these cases. So an object in motion, such as the cat, will continue in motion at the same speed and in the same direction. When the cat strikes the water, it stops accelerating, yet it does not stop moving. Also, the upward force of the water on the cat is balanced by the downward pull of gravity, so the cat will continue in motion at constant speed. And finally, the upward force would first contribute to slowing the cat down before it could begin to actually move it upwards. So it's not possible if a cat were to hit the water to literally bounce upwards off the water. Determining net force. So in these three situations, determine the net forces that are acting upon the object and realize that forces have to be opposite of one another. So while you may have a horizontally, you have two forces working, and then vertically you have two forces working. So here, my force normal, which is vertically upward, and my force gravity, which is downwards, they cancel each other because they're both 3 newtons. And so these forces are equal and opposite, and so they cancel each other. Horizontally, I have a force of friction of 5 newtons versus an applied force of 5 newtons. These are also going to cancel each other out. So overall, I have a net force, and I'll put that as F net. So force net is equal to 0 newtons in this case. I have a net force of 0 newtons. Situation B, Vertically, my force normal cancels with my force of gravity, 3 newtons versus 3 newtons, and I have 5 newtons of friction working towards the left. So my net force, my F net, is going to be 5 newtons left. Situation C, I have 20 newtons of my normal force versus 20 newtons of gravity, and since these are opposite of one another, the net force again is also 0 newtons. Lastly, situation D, I have 40 newtons vertically versus 25 newtons downward due to gravity, and so my net force is going to be equal to 15 newtons upward. All right, in these examples, what would the letters have to be in order to accomplish the force stated? So if this has a net force of 0, then B, being the opposite of the gravitational force, your force normal, this is going to have to be 200 newtons to cancel out that downward force. And to the left, A, is going to have to be 50 newtons in order to cancel out that force to the right. Okay, F net is 900 newtons going upward. So if I have 200 moving downwards, then I'm going to need 1100 moving upwards because they're going to subtract from each other, canceling by 200. The third one, if I have 60 newtons to the north, 60 newtons to the left, the letter E is going to have to cancel. So the bottom force, the downward force, must be 300 newtons also. And then if I have 60 going to the left, then there must be an opposite to the right of 20 newtons. Finally, this has a net force of 30 to the right. And so whatever your force of vertically is going to be, F and H, it doesn't matter what they are as long as they're equal to each other. So whatever the case, F is going to be equal to H. And then finally, in order to have 30 newtons going to the right, G must be 50 newtons. And there's your answers. Newton's third law, every action has an equal and opposite reaction, so forces come in pairs. So every force has an equal and opposite force. Here's an example. In the top picture, Kent Budget is pulling upon a rope that is attached to a wall. In the bottom picture, the Kent is pulling upon a rope that is attached to an elephant. In each case, the force scale reads 500 newtons. Kent is pulling A with more force when the rope is attached to the wall, with more force when the rope is attached to the elephant, or the same force in each case. Your correct answer is going to be C, the same force in each case. As you can see what he's pulling against the wall, it's a force of 500 newtons. It's still a force of 500 newtons pulling against the elephant. So even if the elephant is pulling back against him, he's still pulling at the same force in both case scenarios, 500 newtons.